Hello students and welcome to part 4 of our course. Today we're actually moving into talking about a concept called resistivity and resistance. So we're kind of getting into this mindset of circuits. So as I've stated before, the tradition of what we do, we've been actually studying for the past few weeks the idea of charges, and last week we started getting into the concepts of modeling how a capacitor behaves. So we started getting into the idea of how can we use the physics and the knowledge that we learn and apply it in real life situations. Well, I want to get you guys in the mindset that we're going to start working with circuits. So next we'll be just talking about Ohm's law, simple circuits, and Kirchhoff's rules. And these are all pretty much applied physics techniques. But before we kind of get into circuits, we're going to kind of go into some more fundamental concepts, and we're going to be talking about resistivity and resistance. And then I'm going to start giving you an idea of what is a circuit and a little background on that, because we're kind of moving from this theoretical physics and applying the theory that we have learned, but we still need a little bit more theoretical background. So this week we're going to be covering resistivity and resistance. And even though these words sound the same, there are some slight differences between these two terms, and I'll define those a little later. But before we get into what is resistivity and resistance, let's get to the idea of what a simple circuit here is. So here is just a diagram of a simple series circuit. We're going to have more labs about circuits, so I'm not going to go into details. But what you see here is this is a circuit with a battery and then a single resistor. And I'm just going to talk about what are some of the things or the physics behind a circuit. So the three big things that you're going to see when you have a circuit are these things. You're going to see a voltage or electric potential. So this kind of like a capacitor, right? One side of your circuit, or like this could be a battery, or this could be an outlet. Like let's say this is 5 volts. One side is positive, one side is negative. So just go back to the theory about the magnetic fields and stuff. You know that a positive charge is going to want to go towards a negative charge. So this is what voltage is. It's basically the measurement of your electric potential and that energy. So it's basically your power source. So this could be like a 5-volt battery or something like that. So that's what voltage is. Another thing that we will often be talking about is going to be current. So current is basically going to be the flow of your charged particles. For the purposes of our course, the charged particles are going to be electrons. So it's going to be the flow of electrons moving through a conductor. In our case, like your circuit, like a copper wire or something like that. And the SI units for current is going to be amperage. And basically what it measures is the amount of charges that you have moving per second. So basically it's a measurement of how fast a charge can move around your circuit all the way to the other side, right? So that's what current measures. And then the last thing that we're going to be talking about is resistance. And this is kind of the main focus on this lab. We're going to be talking about resistance and resistivity. But basically resistance is a measure of how difficult it is for a current to flow through something. So you can imagine this is like water, right? Another term for voltage that people use, or a way to describe it, is kind of like pressure, right? So it's like the pressure difference is something that some people may say. And then current is basically the flow of that pressure, kind of like water. And then your resistance is like something maybe like a clog in a sink that's slowing down that flow. So you could think of these three things like this. You have your voltage kind of pushing your electrons through, and then you have your resistance trying to slow it down. So this is a good way to think about this. And of course, next week we'll be talking about Ohm's law. So these are kind of related towards each other. So voltage is going to be equal to your current times resistance. And that's not so much important for this week, but this is just a mindset we need to get in. So this week what we're going to be talking about is resistance and resistivity. So we already kind of have an idea of what resistance is, right? You have some electron coming through and it hits your resistor and it wants to slow down. So resistance, the definition is it's slowing down your electrons. Now resistivity is basically the physical property of the material that you have, right? Having some dimensions. So this is material dependent. So if you have copper, brass, things like that, they're all going to have different resistivities depending on what type of material you have, right? And a few things affect resistivity: the length of your material and the shape of your material. Now, for the purposes of this course, we're going to be looking at the resistivities of wires. So all our materials are going to be cylindrical, like a wire. So your resistivity is going to look like this, where it's going to be basically the length and the area. And the equation for resistivity is given here, right? So your resistivity is equal to your resistance times your cross-sectional area divided by the length of your wire, and that is equal to resistivity. Now your resistance is going to be equal to your voltage divided by your current. That's kind of why I showed you that on the last slide. We're going to be doing another lab called Ohm's Law, so this equation you'll be seeing again. But I just want to, for completeness of this course, I just want to give you the information now. But resistance is also equal to resistivity times your length divided by your cross-sectional area. So resistance and resistivity, they are related to each other, right? Now there are some differences that we need to point out, like the SI units for resistance, it's going to be ohms and it's going to be using omega. But the SI units for resistivity, and this is going to be a quiz question, is going to be ohms times meters. So resistivity is ohm meters, resistance is ohms, because they are, even though they're related, they are two different things. So you cannot use these words interchangeably. Resistivity is like saying I have copper. The resistivity of copper is this value, but resistance is different. They are related to each other, and they're related to each other by these physics equations, right? So here's how resistance is related to resistivity, and here's how resistivity is related to resistance. So keep that in mind. Another cool thing about resistivity is, like, for example, maybe you have some wire at home, right? Well, if you know the resistivity of your material, if you know the cross-sectional area or the gauge of your wire, if you measure the resistance, you could actually calculate the length of your wire. So let's say you're an electrician and you want to do a project and you don't know how much wire you have. Well, you could take your voltmeter and you can measure the resistance, and you could look up the resistivity of your material, like you have copper wire, and you could measure the gauge of the material, the cross-sectional area, and then you could actually calculate how much wire that you have. So there's an example of a real-world application that you could use for this. Now this is going to be something that you're going to be doing in your lab. So they're going to have you doing some plots. They're going to actually have you plotting resistance times your cross-sectional area. So if you look at this equation here, your resistance times your cross-sectional area, this is going to be your y-axis. And then they're going to have you plot that versus the length of your wire. So if you notice, if you take the slope of this, right, this divided by this, is going to equal your resistivity. So your slope is going to be equal to your resistivity. Now, the introduction to your lab worksheets gives many examples on how, like, you do these graphs on what the slopes represent. So go through your worksheet and think about this. But essentially, I want you to be able to look at these physics equations and ask yourself, what are you plotting? So if this is your y value and you're plotting it versus your x value, then your slope is going to give you this physical quantity. So try to think about that when you're doing your graphs. What does my slope represent? Okay. So a few things that we should know for this week about resistance is what can affect your resistance. So we need to start getting into the practice of looking at our equations and thinking about how does our equations tell us about our system, or what we're trying to look at about what does the physics of the equations tells us, right? So one of the things you could say is, okay, what can affect resistance? Well, you could say the length of the wire, right? So here's a L. So as the wire gets longer, our resistance is going to change, right? What else could affect resistance? Well, the cross-sectional area, right? As we change the gauge or the thickness of the wire, our resistance is going to change. So as this gets bigger, as A gets bigger, our resistance will get smaller, right? Assuming that everything else stays constant. And we could say that as L gets bigger, assuming that rho and A stays constant, R will get bigger. So these are some things that we could stay. So we need to start looking at these equations and ask ourselves, what happens when we change the parameters? How will our resistance change? Another thing that could affect this is the type of the material, right? Remember, resistivity is based off of material. So our resistivity can affect our resistance depending on what material we're using, how long the wire is, or how long a material is, and the cross-sectional area of our material will determine the resistance of the material. So these are all things. And another thing that your lab talks about is temperature. They don't give you the equation, but here's the equation how it relates, but it's not a focus. But temperature is something that affects your resistivity. So typically, as the temperature increases, I believe your resistance will decrease. Okay, so these are the 4 examples that you will need for your quiz, or some ideas that you need for your quiz. You'll do very well on your quiz if you're able to look at this equation right here in particularly and ask yourself, how does resistance change? Another thing to point out is you just focus on looking at these equations right here. All right, resistance rho times L divided by R, and then this equation, because they could be asking you questions. How does resistivity change depending if your cross-sectional area is larger or smaller, and so forth. So those are the type of quiz questions you can expect. Now, again, your lab is going to be very straightforward. In the simulations, what you're going to be doing is essentially changing the length, the cross-sectional area. You're going to be filling out tables, and you're going to be producing graphs. So again, just like every week, if you have any questions, please feel free to reach out to me or attend office hours, and I'll be more than happy to help you. Thank you and have a wonderful week.